So what are some of the differences in heat pump compressors versus air conditioning compressors? First of all, the operating hours. Heat pumps generally operate 7 times longer each year than air conditioners do. They also operate in a much wider range of system conditions. A typical application of a heat pump is 20-degree outdoor ambient with evap temps of 5 degrees. Severe environment conditions are 0 degrees to minus 10 degrees with condensing temperatures of minus 15 to 110 degrees. Compression ratios are also higher. Air conditioners usually run 4 to 1. Heat pumps normally run 8 to 1. As compression ratios increase, bearing lubrication and discharge valve temperature will be affected. Another difference with the heat pump compressor is the liquid refrigerant return. During low ambient operation and defrost cycles, it is more likely that liquid refrigerant will be returned to the compressor. You may find a compressor iced up like this, which means that liquid is returning back to the compressor. When liquid is introduced into the suction side of the compressor, depending on what kind of compressor it is, it can do immediate damage or it can do long-term damage by washing out the bearings and causing the bearings to fail. You don't see too many reciprocating or piston compressors anymore, but when they were popular, the pistons on the reciprocating compressors were usually a lot beefier on heat pump models to endure the conditions that they would endure in a heat pump operation. Also, the reed valves on piston compressors were always susceptible to damage by liquid refrigerant slugging. When the Copeland scroll hit the market, one of the marketing ads was that they could pump liquid. And it is true that the orbiters on the scroll compressor are less susceptible to liquid slugging damage than the reed valves on the piston type compressor. But scroll compressors can be damaged by liquid slugging also. And so it is very important to maintain superheat into a scroll compressor just as it would be on any other type. Copeland and all other manufacturers of heat pump compressors have dedicated heat pump compressors that, as we've said before, are stronger and have more beefier components in them for heat pump operation. As we've seen, the environment that a heat pump compressor operates in can vary from very cold temperatures to very hot temperatures. More and more we're seeing rotary compressors becoming more prevalent in the AC and heat pump field, and for good reason. They're a very good compressor, very reliable, and the design lends itself to less damage from liquid slugging. Also, on a rotary compressor, you will normally find a liquid accumulator on the side of the compressor, which in this picture is numbered number 3. And in that accumulator, it has a screen so that any liquid coming back to the suction line is going to be dissipated and will boil off before being sucked into the compressor. So the rotary is a very good design for any kind of hard operation such as the heat pump, and the numbers show the results that there's very few failures on rotary compressors on heat pump applications. Along with the rotary compressor technology, inverter technology is everywhere, and you're beginning to see inverters in just about every AC and heat pump unit that's on the market today. In an HVAC system where the compressor is controlled by a contactor to start the compressor, which is sitting there idle, the compressor must go from 0 to operating RPM in a matter of seconds. As with the tires on an airliner hitting the runway, this puts the compressor under great stress at startup. But in an HVAC system where an inverter controls the compressor operation, the compressor starts slow at low RPM and depending on load will slowly ramp up to operating speed. And when the cycle is complete, the inverter will slow the compressor down gradually to complete shutoff. This reduces the wear and tear on the compressor, increasing the life of the compressor.
Go to arefco.com for more videos, like, subscribe, and check back every week for new videos.